Okay, so thanks for the introduction. My name is Björn, as said. I'm a production engineer at SoundCloud, and I'm dealing with essentially two things. The one thing I deal with is the system that runs all the other systems, which these days mostly boils down to Kubernetes. And then I do monitoring, which mostly boils down to Prometheus at our company. Prometheus was mentioned quite a few times during this conference, which makes me proud. I'm also co-developer of Prometheus, and so you can guess what the main subject of this talk will be. Before SoundCloud, I had many previous lives, and I experienced a lot of blasts from the past recently. There's an obvious link to my past as a site reliability engineer at Google. The most obvious one is actually not there, which is Go. I've never done Go at Google, sadly. I only did this when I left the company. But there's a funny connection with Go because my very first language I learned at school, and I'm exceedingly old, so it was not Java, it was not Python, it was actually Pascal. And last year at GopherCon I learned Pascal is the great-great-grand aunt or something of Go, so there's a connection. Now Go is haunting me, Kubernetes, Prometheus, they're all coded in Go, and many other things, and they're all important for my life now. Another interesting thing is music. So SoundCloud is a music streaming service, as you might know. And what's the connection to my job? Like, sadly, I'm not linked to the product of SoundCloud in my day-to-day work, but I studied musicology as my first subject at university. So there's a funny connection, and I also think of coding as something musical, like creative. So perhaps there's a connection in musicology. And are there any musicologists in the room? Because then you know what the title of the talk means. I think it's a fitting title, but the reason is this book. This is from 1844. It's written by Hector Berlioz, one of the greatest French composers of all time, and he wrote about instrumentation and orchestration. Interesting, right? The distributed system was obviously not computers. It was like musicians in a symphony orchestra, so this is really musical. But the funny connection is my very first thesis I wrote at university was about this book. And nowadays I'm dealing with orchestration all the time with Kubernetes, and I do all the instrumentation for Prometheus. So circle is complete. So this talk is about instrumenting Go code for Prometheus, the fact that Prometheus and Kubernetes are both written in Go, and that you might run your programs on Kubernetes and you might monitor them with Prometheus. That doesn't force you to use Go for your own programs. But I guess we are all happy Gophers, and I have to convince nobody that you should write your next distributed application in Go. I might need to convince you that you should instrument it for Prometheus. So why Prometheus? There's a nice sentence. It's in this by now famous site reliability engineering book Google published earlier this year. We need monitoring systems that allow us to alert for high-level service objectives, but retain the granularity to inspect individual components as needed. This is spot on. This is the incentive we had when we created Prometheus at SoundCloud. This sentence is not about Prometheus, it's about the way Google does monitoring, but as you might know, there is some inspiration between Google's monitoring system and Prometheus. So that is a nice fit. I also like to quote myself, Prometheus' ability to monitor different layers in the cloud native stack with the same semantics is vital. So even in the old world, when you had to monitor your hardware and your network and your actual application, it was already annoying that they were all monitored by different systems with different semantics. Now you have to monitor your containers, and then you have so many containers that you need an orchestration system, which you have to monitor as well. So it gets more and more complicated. All these other layers don't disappear, even if they are somewhere in the cloud. And it's quite nice that you can do all of that with one semantics, one monitoring system, and things like cAdvisor, Kubernetes, and etcd, to name a few, they are already integrated with Prometheus, so that's good, and the missing piece in the puzzle is your code, right? So this is why I'm here and talking about how to instrument your own code. Even if you don't end up using Prometheus, this instrumentation is not in vain. There is an open system, there are many integration points, so you can still use other monitoring systems with that instrumentation. So let's stick to quotes. This is St. Peter, more Holy Scripture. Peter sits here. ideally, you should read it outright, but anyway. So you should be instrumenting every significant component of your code base. If it's a resource, like a queue, instrument it according to Brendan Greig's use method, utilization, saturation, and error count. If it's something like an endpoint, instrument it according to Tom Wilke's RED method, request count, error count, and duration. So there were kind of other people quoted in the quote, it's like the meta quote. So I never read out the rate. I always said count. And Peter already parenthesized the rate, and we will learn later why counts are kind of superior to rates with the right tooling. So keep that in mind. Keep all the other things in mind. We will come back to that later. Just one last quote, again from the SRE book, which is a nice agreement with Peter's quote. The 4 golden signals of monitoring are latency, traffic, errors, and saturation. If you can only measure 4 metrics of your user-facing system, focus on these 4. There's a long chapter about those 4 golden signals. It's super interesting. It's a golden read. You should definitely do that. It will help you a lot. In this talk, we will not do so much about the theory. We'll more look at the practice. How do you actually instrument your code to have those signals? So how does the instrumentation and the exposition of metric work with Prometheus? This is really similar to XBAR, which you might know from the standard library, and XBAR is also not in isolation. This is not some weird idea that some Go standard library developer came up with. This is good old Google tradition. At Google, every binary has something like XBAR, and there's a monitoring system called Borgman that scrapes those endpoints. So this is kind of similar, and Prometheus is inspired by Borgman, so you see the link here. So XBAR is, again, a kind of inspiration circle that is completed here. Prometheus uses a different endpoint. It also uses a different format, so it's not JSON, it's protobuf, but it has many more semantic differences. It's typed, so you have counters, gauges, histograms, and summaries in the metrics. It's documented, which is really valuable in practice. And it has labels, arbitrary key value pairs, while XBAR has a hierarchical tree. This whole label idea is also something kind of newish. It's present in Kubernetes as well, which is a nice fit again. So the Prometheus client library for Go gives you all of this and a bit of plumbing to manage and leverage the above. In principle, you don't need the client library. You could just create this payload with your bare hands. You could even produce protobuf. Protobufs are described in a proto file, and then there's a protobuf compiler that creates the bindings for different languages. The Go one is not very idiomatic, unfortunately, but it works, and then you can use this generated Go code to create protobuf objects, let's call it objects, and you can serialize it to the wire. Protobufs are nice because they are easy to serialize and deserialize and have a nice on-the-wire format, all of that. This is just the text representation here on the slide, so you get an idea how it looks like. It's really structured and everything. Some people actually do that, and they create protobufs with their bare hands. More people are creating the text format, which is an alternative format in the Prometheus world. It's all flattened down to line-based metrics. You can do that as well. This is handy. You could basically curl your way out of Exposition in a shell script. Some client libraries only create that text format. The Go client library creates protobuf if it talks to a machine, but if you take your browser and go to that endpoint, you see the text format because it's way more readable. Okay, so this is the format you could generate with your bare hands, but we want to do it with the client library. It's much easier. How does that work? First step, you import the prom HTTP package, and then you take a handler from there, and you use that handler as you're used to, and you can serve HTTP. If you do nothing else but that, and you look at that metrics endpoint, you see something like that. That's just a short, a few lines, selected lines from that output. So you see something like, does that work here? No, it's too weak, right? Anyway, you see all those go_GC, go_something. These are Go runtime metrics. You get them for free. You get statistics about your garbage collection. You get the number of Go routines, all those things. And you also get process_something metrics, which is basically exported by every client library. So even if you write a Java program, you will see those metrics. metrics. Obviously, you will not see any Go metrics then. And without having done anything else, you can already point your Prometheus server to that endpoint, and you can ask questions like, how many Go routines am I running company-wide? Might not be meaningful, but you get it, right? So nothing done. This already works. Now we want to instrument proper stuff and get interesting, not just generic number of Go routine metrics. So let's have an endpoint. I've written a really crude endpoint. Don't judge me on it. There's some mysterious compute result function that computes a result, might spit out an error, and then I serve it via HTTP. Really? This is way too weak here, right? Yeah, okay, I'm sorry. So I can point here, right? So this is where I serve it via HTTP. If I get an error, I return a 500 or 503, depending if it's a timeout or some other error. And that's basically it, very simple. And now let's instrument it. It's an endpoint, use the red method. So what is the D in red? That's duration, and you usually do that with a histogram in the Prometheus world. Histogram is a glorified selection or collection of counters. It's basically buckets, and you count how often one of your request durations falls into one of those buckets. You give it a name, you give it a help string, and then you pick buckets. You can just use the default bucketing scheme, which looks very similar to this one. But in general, you should just pick buckets that are interesting for your use case. So you should have fine granular buckets where you're actually interested in the latencies, but if your timeout is a second, there's no reason to have a 10-second bucket there or something, right? So that was the D. Now the R for request count, we have a counter. Now this is not just a count, it's a counter vec, which is short for vector. Vector is a central Prometheus thing. If you have a metric, you can attach labels to it, and then suddenly you get all those key value label combinations, and you have many metrics for the same name. So this is a vector now. In this case, we just have the status code here. So we don't just count requests, we count them separately for each status code. In that way, we are basically getting the R and the E in red because we count errors and successes separately. In HTTP, you might not even be sure, it's like a 404 really an error, or have I successfully told the user that this URL doesn't work? So it depends on the situation, what you consider an error or what not, and you can ask all those questions later with Prometheus. Once you have created those metrics, you have to register them with the Prometheus registry. That might go wrong. This is where I put a must here. So you couldn't register the same metric twice, for example. Or it checks for consistencies, and you already know if it will work out or not. Now we have to use the metrics. So we have to add those 6 lines to our endpoint. Here's what you see. The defer feature in Go comes in really handy here. So we defer a function that takes the time of now, and as we all know, the function arguments are initialized immediately while the body of the function is actually deferred. And then you want to observe your duration, and that reads really nicely. You observe the time since begun in seconds, right? So this puts a counter, increments a counter into your histogram with the right bucket is incremented. And then we want to count requests, and we want to count requests by status code. So this is where it gets a bit more complicated. So we need Prometheus labels, and we set the status to the status code. It has to be a string, so we have to format that into a string from that integer, and then we increment that counter. And that's it. That's everything you need to do to have a red instrumentation for an endpoint. This is really super low level, and I will show you a few things about PromQL. This is not a talk about how to operate a Prometheus server and how to use the expression language. So it's just like a blast through some possibilities so that you believe me, this is actually possible. So the Prometheus server, when you set it up, has a little web UI where you can hack in PromQL expressions and you see the result. By default, just a single point in time, but you can also graph it over time, so you get nice graphs, and then you can use the same expressions later to have nice dashboards in Grafana, or to put it into alerting expressions. Same expressions, you can use that. If you can graph it, you can alert on it, so that's really nice. If you just type in a metric name, you get what you see here. You get all those different key value combinations with their value. Now you see here, there's our job label, right? our status label, sorry, 200s, 503s, we haven't served anything else. And then there are new labels. There's a job label, which is something I configured. When you tell Prometheus to scrape jobs, you have to tell it a job name, and then it will show up as labels. And you see where it has been scraped from, localhost something. I mean, this is all running on my local machine. In reality, it will be somewhere in your cloud. And this is where you see you can drill down to individual instances if you need to do that. Okay, so this is not useful because you just see how many requests you have served, and you don't even know when this counter has started, right? But if you take into account the time dimension, you can take rates. So you can look at the last 5 minutes, how much has this counter increased, normalized to per second. And then you get QPS, right? So you see every instance how many QPS they have served with which status code. So this is pretty nice already, but you want to aggregate, so you can sum it all up. So this is QPS you serve fleet-wide. Unfortunately, now you don't know how many errors you've served and how many successes. You can modify your aggregation. So this shows you now how many QPS per status code you have served. You can also look at individual instances, and then you can kind of do both, and then you're back where you started, just that you still see the job label, which is interesting because you might have different jobs. This is the histogram. As said, you can just later look at the videotaping and try this out at home. I won't explain the details here, but this is, believe it or not, this is average latency, which you can get from the histogram. Average latency is often not a good metric. You want something, oh no, wait a second. This is interesting. You can actually look for error codes specifically. Wait a second. This was the wrong slide. This is not average latency. This is error rate, right? So this is just 18% of our requests are errors. And this is the same thing, just aggregated in different ways. Like I can actually see now I have 18% errors fleet-wide. So where's this error coming from? Is this just one instance or all the instances? And then I can look at individual instances and see 1882 is actually fine and the other ones are not so fine. So this is the latency, the average latency, 198 milliseconds. Again, you can look at individual instances, but usually you want percentiles. That's possible as well. So this is the 90th percentile fleet-wide, or again, like sliced and diced. By the way, whenever you have a monitoring system that tells you it can aggregate percentiles, quantiles, be suspicious because many systems don't get that right. Prometheus gets it right. Okay, so now just as the last blast here, this nice contraption, somebody might know it's like metrics professional, that's an AppDex score. So if you're a fan of AppDex score, you can calculate that from a histogram as well. Okay, as said, this is just as proof. You can do anything, you can ask all the questions. We are concerned just with the instrumentation part here, and we are still missing use. I mean, the E from use is already there, but we need utilization and saturation. Utilization is often just something like, what fraction of time have I used a resource? And that can be measured again with the counter. Counters just rule. You count seconds you have used a resource. So here I simulate a resource that can be used by a single Go routine at a time by putting a mutex here. I mean, it's just to show how that works. And then again, use this defer feature to add time since begin in seconds to this resource usage counter, and then you get total time you have used that resource. Again, by alone, that's not very helpful, but if you use a rate, then you get seconds per seconds. What seconds per seconds? That's just the fraction you have used that resource. Like if that expression evaluates to 0.8, you know I have used that resource 80% of the time. So, utilization, done. Saturation. That's more like in a queue, and a queue in Go is often implemented as a buffer channel. And now the channel, this is really neat because it acts like a queue, and it already has metrics if you want, because you can ask a channel for the length, like how many items are currently waiting in the channel, and you can ask for the capacity, how many items could you put into the channel. And you get an idea if it's already full or how much it is full. Now this is a bit problematic because we don't want this metrics object as before where we set values or increment it. We already have the value, we just want to serve it. This is, by the way, not a counter always goes up. This is a gauge, like in your car, it goes up and down, like a channel gets fuller and emptier. And now we need a method to serve this value directly without having any metric in between where we have to set that value. And that's done with the gauge func. So this behaves like a gauge, like a metric. You could also create a standalone gauge where you could set values. But this is something where you never set a value, but the moment you hit the metrics endpoint, the Prometheus client library will call this function here, which is just give me the length of the channel at the moment and return it as on your metrics endpoint. So that's it, right? That is saturation, and you can kind of create metrics on the fly for numbers that are already somewhere in your system. So we are basically done, right? Use, read, all good. Now there's one problem. Sometimes you don't have your own code to instrument. You use code of others. That happens now sometimes, right? Not invented here and things like that. So let's say it's closed source or it's an open source project that certainly won't accept your upstream contribution with Prometheus metrics. Let's say Apache or MySQL. What are you doing then? You need something. Often those systems already have metrics in some way, and you need a way to get those metrics into Prometheus. And we are calling that an exporter in Prometheus lingo. I mean, you're kind of importing the metrics into the Prometheus world, but from that product's view, you are exporting them out there to Prometheus. So we call it an exporter. It's a little binary that asks that system for metrics and transforms them into something Prometheus can understand. Those little exporters are often written in Go, sometimes in Python, but yeah, this is Go conference, so let's look at Go. Or let's first look at what are we actually doing here. So Apache is a good example, very old software. It already has some kind of instrumentation. If you load mod status, you can hit that endpoint, localhost server status in this case, and you get metrics. That sounds really familiar. It's like XVAR, it's like Prometheus. It's just yet another format. Also, those metrics are interesting, right? So total accesses gives you the number of accesses this Apache server has seen during its lifetime. That's a counter, right? That's a Prometheus counter. We would probably call it Apache accesses total in the Prometheus world. And then there is another counter, how many kilobytes has this Apache server served. This is Apache send kilobytes total. Counters, right? Easy. So now there are other things like requests per second. And as a Prometheus Pro, you already know, I can calculate that. I can calculate that from the total accesses counter. And bytes per second, same thing. I can calculate that from my send kilobytes counter. And even bytes per request, I can just divide the calculated rates by each other, and then you get bytes per request. So those things are kind of redundant, right? They're only there because not everybody who uses Apache has something like Prometheus and can calculate the ones below from the one above. We can do this with Prometheus. We only need the numbers above. And they're even superior because here you don't even know, like we can tell Prometheus the time frame, like give me the QPS over the last 10 minutes. We don't even know, is this over the last 10 minutes or 10 seconds? It's probably documented somewhere, but even if we see it, find it, we can't change it, right? If we are interested in the last 10 seconds and not the last 10 minutes, there's no way we can change that here. Also, we might miss load spikes. Like if you have a huge, very short load spike in the QPS, this QPS value, request per second, will go up, and then it will go down again, and we haven't scraped it, we will miss it. While the counter is just has gone up, right? No requests left behind. We can always see how many requests we have served. Okay, so the only thing we need a little program that reads this server status thing, converts those two numbers into Prometheus counters, and then we are done, right? Now the problem is you might want to use a counter func for that, which is like a metric that calls a function to create that counter, and that function would call out to Apache, to that endpoint. With 2 values, that's probably okay, but if you have 100 metrics in that output, and for every single one you scrape the whole thing from Apache just to parse out a single value, that's probably not efficient. So we have a problem, how to collect multiple metrics from the results of a single call, and this is where I have to go into the guts of the client library. There's a collector interface in the client library, which is whenever you register something, register a metric, then this thing you register implements the collector interface. It has a describe method, which describes the metrics you're about to collect. so it can check for consistency, naming collisions, stuff like that. And it has a collect method, which is called when you are actually collecting metrics. So let's imagine we could implement a Apache collector with all those methods, and then we could register that collector, and we are done, right? So now how to do that? To do that, first of all, we need to create descriptors. Descriptors have been created all the time, just it was all happening behind the scenes and you didn't need to do anything about it. Now we have to do it. It's luckily pretty easy. In the easy case, you basically just need a name and a help string. The nils there are for dimensionality. Like if you have labels on those metrics, it becomes really complicated. This will also be simplified in an upcoming version of the client library. For now, if you don't deal with labels, this is all easy and fine, right? So you create two descriptors for those two counters we plan. And then here, the describe method is really easy because you just send those descriptors to that provided channel and you are done. The collect method is a bit more involved. There's a magic retrieve and parse mod status output, which somebody has implemented for us. So this gives us the two values, readily parsed, and it also gives us an error if something goes wrong. If really something goes wrong, you can tell the Prometheus registry about invalid metrics with those descriptors, so it can create nice error messages, which metric actually wasn't collected properly. But the usual case is this weird must new const metric. So what is that? In this case, we don't really need a complete metric object with methods to increment the counter or something. We just need something to throw away to serve it, and then we are done with it. So that's a const metric that has no method to be changed, and you just create it on the fly. You give it a descriptor, you tell it that it has a counter and not a gauge, for example, and you tell it the value, accesses or send it to that channel, and the rest is done by the client library. So you've written your exporter and you're done. Okay, this will change a bit in the next version, but there we are. We are at the end of this talk. There is no Q&A, as we know by now, but you can always grab me in the hallway. I'm easy to spot, because I'm probably the tallest person here. Okay, thank you.